Look at this stuff. Isn't it neat? Wouldn't you say my collection is so much better than the poor suckers who have to teach with chalk? Woo! So much dust everywhere. Of course, on the other hand, I've got fumes for markers. I'm in an enclosed office. Now you know why the videos are short. Okay, we are going to talk about how to set up your null and alternative hypothesis. And that is not an easy thing to do. It requires you to read the question and understand it, and then put the question into math symbols. So let me give you a couple of rules that are going to help. A null hypothesis always has an equal sign, whereas the alternative will never have an equal sign. So at the beginning, when all we're testing is mu for mean, your null hypothesis has basically three choices. It could be that it's equal to 12, less than or equal to 12, or greater than or equal to 12. The alternative is going to match. Equals 12 means it would have a not equals 12. Where did I get 12 from? Well, you got to read the scenario. We'll talk about that in a minute. 12 is just an example. But if it was less than or equal to 12, your alternative is going to be greater than. If it was greater than or equal to 12, then your alternative is going to be less than. Now, the null hypothesis is what you assume to be true. It's the model you believe. And that's important because when you're doing the math, you have to have a mu that you put in. And here you have that mu. So the math needs the null hypothesis. The alternative, on the other hand, that's something you can prove. Remember that if the null hypothesis ends up being realistic, that can't prove the null hypothesis. We'll spend a longer video talking about this in more detail. But the null hypothesis, if you assume it to be true, you can't use itself to prove it true. So for that reason, a lot of research specifically aims for an alternative showing what they want to show. Now, when I use the picture, it's the alternative I look at. So you may find the alternative to be the more useful, even though theoretically the null is what's driving the model. Let's do an example. I just went to weather.com. It says in Laramie for May, the average is supposed to be 1.69 inches of rain. It seems like it has rained an awful lot lately. So if I randomly sample 36 days in May and I get an average of 1.88 inches, can I prove the weather.com is wrong? I'm missing a standard deviation. It should have a final sentence saying assume sigma equals 2 or something like that to actually do a hypothesis test. But we just want to practice the null and alternative. So I see a couple of numbers here, and standard deviation should be on there, but that's not where our null and alternative is going to come from because we're testing the mean. We want to test the average. There's two averages on the board. We have a 1.69 and we have a 1.88. Our null and alternative need to be about the parameter, not about the statistic. So which of those two numbers is a parameter? Ask yourself, if I redid this study, which of these numbers would change? If I resampled 36 days, would this number change? The answer is no. But this number would change because that depends on who I randomly select. So that is not where my null and alternative come from. My null and alternative need to come from this 1.69. So what does it say? It says the average, that's mu, means equals 1.69. So mu equals 1.69. Does that have an equals in it? Yes, in fact, that's exactly what it does have, is only an equals. So that means it's a null hypothesis. Mu equals 1.69. Now that I have the null, I can do the alternative easy. Mu does not equal 1.69. Do not fall into the trap of thinking that whatever the question says is the null hypothesis. Let me show you an example of why. For this homework set, I think it should take you less than 5 hours on average. Some students need longer, some students need less. My standard deviation is 2. I randomly select some students. I get an average of 6.2. Does that suggest that it's taking too long or not long enough? Okay, so I need to try to put this into symbols, and I've got lots of different symbols here. Where's my parameter? If I redid this study, which number would change? This 6.2 would change. That's a statistic. I need the parameter. The 5 hours is what would not change. That's what I believe without data. And so that's my parameter. I believe the average, that's my mu, is less than 5. Now don't get sucked into the trick of, because it's what I believe, that's the null hypothesis. I just told you 2 minutes ago, the null hypothesis is what we believe to be true, but it's what we believe for doing the math. In this case, mu less than 5 does not have an equal sign, so that needs to go for the alternative. The alternative is mu is less than 5. The null here says mu is greater than or equal to 5. So when I draw my picture, 5 is what I'm going to put as my mu. That's what I believe to be true. Whereas the alternative, less than 5, is some vague but non-specific number. So the math is going to assume 5 because it has to have, woo! Okay, this video is long enough. It has to have a number for doing the math.